So, good morning बच्चों. Today we are going to start our new chapter electricity as we have promised to start this chapter. तो इस चैप्टर में हम लोग कुछ चीज़ें पढ़ेंगे. जैसे क्या क्या चीज़ पढ़ने वाले हैं हम लोग. जैसे सबसे पहले हम बात करते हैं अबाउट इलेक्ट्रिक करंट. So, as we know the nature of the charges and also know about the potential developed across the conductor. तो अब क्या हो रहा है कि नाउ वी आर गोइंग टू स्टार्ट द फ्लो ऑफ चार्ज इन डायरेक्शनल वे. तो हम क्या करेंगे, अब चार्जेस को क्या करेंगे, इन द डायरेक्शन वे में क्या करेंगे, मूव कराएंगे. एंड आफ्टर मूविंग द डायरेक्शनल वे इन अक्रॉस द कंडक्टर, that will be ultimately called electric current. So here we have to know what is electric current actually. So basically the charges in the conductor, तो free electrons जो conductor में होते हैं, the free electrons that are present in the conductor moves randomly over the entire lattice randomly, and the speed of the electron randomly may be considered that 10 to power 29 per meter cube in the given volume of the conductor ये present होते हैं. Now as soon as we apply the potential difference across the conductor, when we apply a current, the electron, the free electron that is present inside the conductor start to move in just opposite direction of the applied electric field. Now this is called what? Electric current. So basically we have two kinds of current present. One current is called the electronic current, that is current of the electrons, and second one, that is the electric current. It is our conventional current that we are getting in the circuit. So what is the electric current? Electric current is the rate of flow of charge. I is equal to Q by T. इसी को क्या कहते हैं? इलेक्ट्रिक करंट कहते हैं. And here Q is the charge, the number of charges that is present inside the conductor, and T is the given time in which they flow from one point to another point. Here we can also write the unit of the electric current as the unit of charge is coulomb and the unit of time is second. So unit of electric current is coulomb per second, and 1 coulomb per second is also called 1 ampere. Now you well know about the ampere. It is the fundamental units in the physical quantity, and we have to define it in terms of international definitions. तो इसको हम लोग क्या करेंगे, मैग्नेटिज्म चैप्टर में क्या करेंगे, 1 एम्पियर को डिफाइन करेंगे बेस्ड ऑन द टू पैरेलल वायर ऑफ इनफिनिट लेंथ इन विच currents are flowing. But here we have, if we wish to define the electric current, तो on the basis of charge to the time हम क्या कर सकते हैं, 1 एम्पियर को डिफाइन कर सकते हैं. तो 1 एम्पियर करंट क्या है? व्हाट इज द 1 एम्पियर करंट? इफ 1 कूलम ऑफ चार्ज फ्लोइंग थ्रू 1 सेकंड, द करंट corresponding to the conductor will be considered as a 1 ampere. Now it is important to note that current has direction and it has magnitude, but after all of this we call it scalar quantity. Why? Because current does not follow the rules of vector. So this is the reason we consider electric current as a scalar quantity. तो scalar quantity इसको बोला जाता है. Now second topic, after discussion of electric current, we can define the electric potential. Difference in terms of electric current. इलेक्ट्रिसिटी में हम लोग इलेक्ट्रिक पोटेंशियल डिफरेंस को बताएंगे. Now what is the potential difference? It is a kind of work done to bring the charge from one point to another point. एक चार्ज को क्या करता है, एक साइड से दूसरे साइड ले जाने के लिए जो वर्क होता है, that is called electric potential difference. Now suppose that we have applied a cell that is the source of electric potential. When we apply the source of potential difference, the charges start to flow. In the opposite direction of the applied electric field. Here the direction of the electric field will be this one, and the charges will move toward this one. So the motion of the charge, where the charge are moving, may be considered as the electronic current. That will be considered as the electronic current, and just opposite direction of the electronic current we are getting the electric current, and that will be called the conventional current. उसको हम क्या बोलेंगे? Conventional current बोलेंगे. Now again we are going to next topics, that is resistance. R. Now what is the resistance? It is the inherent property of the conductor, and due to this property the conductor has tendency to resist the charges. Charges को क्या करता है? Resist करता है. Or we may also define the ratio of V upon I in for the case of conductor remain constant, and then that constant value is called R. Now it is very clear. इसको हम ये भी समझेंगे आगे चल के कि sometimes people students forget to tell about the Ohm's law. This is not Ohm's law. This is just about the relation of the potential and the current that will remain constant for any kind of conductor, and that constant will call resistance R. So for the conductor, it has been obtained that the value of V upon I remain constant. Now next we are going to discuss Ohm's law. Now in 1826, George Simon Ohm has established a kind of theory related to the conductor for the relation of the potential and the current under the constant physical condition of temperature. So he has been established a theory in which he found that under the constant condition of the temperature, the voltage is directly proportional to what? Current. At constant temperature. So it was practically obtained by the George Simon Ohm in 1826 that under the constant physical condition of temperature, the voltage across the conductor is directly proportional to whatever amount of current is flowing through it. And he, when plot the graph for the conductor, it comes a straight line. So this is what? This is called Ohm's law. तो क्या चीज बताया हमने? इलेक्ट्रिक करंट बताया. The rate of flow of charge is called electric current. Its unit is 1 ampere. 1 ampere may be defined as the 1 coulomb of charge flowing through 1 second. एक एम्पियर बोलते हैं. It is scalar quantity. Now electric potential, the work done to bring the charge from one point to another point. Resistance, it is the inherent property of the conductor that resist the flow of charge, and we may also call the ratio of voltage upon current is called resistance. Here you can find out the dimension and the unit of resistance. तो resistance की unit क्या हो सकती है? यहाँ पे V की unit होती है volt and I की unit होती है ampere. So the unit of resistance is volt per ampere, and remember that 1 volt per ampere is called 1 ohm also. So just like ampere we have defined, we can also define 1 ohm, that if the potential across the conductor is of 1 volt and the corresponding current is flowing through 1 ampere, then the resistance across the conductor will be considered as a 1 ohm. So these are the laws which are important in the electricity. तो ओम्स लॉ में हमने पढ़ा कि वोल्टेज करंट के क्या होती है? डायरेक्टली प्रोपोर्शनल होती है. बट प्रैक्टिकली इट वाज ऑब्टेन्ड दैट इन केस ऑफ सम कंडक्टर, when we are going to apply the Ohm's law, it exactly does not valid. Why? So it has been taken for an instance that if we have taken a kind of electric bulb and applied the source of current to across it. So initially, if we draw the graph between the potential and the current, it will sometimes show the straight line nature that will correspondence to the Ohm's law. But after some time, as the filament get heated, it will deviate something what the Ohm's law define. So, in the case of conductor also, when we have taken a kind of electric bulb and we supply some current to it, the nature of the graph just changes. What? It curves, it changes into curve form. So this graph showing just opposite nature of the Ohm's law. The reason behind it, when we glow the bulb, तो initially the filament of the bulb get heated. थोड़ी समय बाद क्या होने लगता है, वो हीट करने लगता है, गर्म करने लगता है, and after heating the property of the resistance also changes. तो property of resistance change होने की वजह से the corresponding value of the current and voltage also start to change. ये भी क्या होने लगता है, change होने लगता है. So this is what the variation of Ohm's law. Also some other kind of electric instrument, electric devices or electric element such as semiconductor, alloy. So these are also such kind of material that does not follow Ohm's law. So any conductor or any substance that does not follow Ohm's law are considered non-ohmic element, and though they show the variation of current and voltage in curve form. तो वो क्या देते हैं, एक तरह का कर्व फॉर्म में देते हैं. तो in class 12 you have to also study the electronic and you have to also do the practical over the Zener diode, junction diode, PN junction diode. So diode का जो नेचर ग्राफ लेते हैं तो we will not get the straight line, it is just curve nature, and in this way here we find the dynamic resistance. होता क्या है कि we will take the different intercept at any point and we will try to find out the change in the potential in the given interval of time according to the change in the current. So dynamic resistance will be given by Rf or delta R. So it will be the change in the potential and change in the current, that will be the dynamic resistance. तो ये क्या हो जाता है, हमारा dynamic resistance हो जाता है. Now आगे हम लोग क्या चल रहे हैं बताने चल रहे हैं कि what is the free electron model of an atom or what is the free electron model for the conductor or the metal. और इसी में हम बताएंगे क्या कि what is the drift velocity, what is the relaxation time. Relaxation time क्या होता है, drift velocity क्या होती है, free mean path क्या होता है. तो what is the free electron model. So here we are going to define the free electron model. So in the free electron model, basically we know that कि atoms, conductors क्या होते हैं, elements क्या होते हैं. In the case of conductor, there are number of free electron present in their outermost orbit. तो किसी भी atom में क्या होता है, जो suppose that we have taken for example sodium या aluminium या copper लेते हैं या silver लेते हैं या gold लेते हैं. So these are a such kind of element in which there are number of free electron in their outermost orbit. तो जो inside के जो orbit में electron होते हैं, they have a kind of interaction with the nucleus. Parent nucleus से क्या होता है, उनका एक तरह का interaction होता है. They are bounded with, we can say, a kind of nuclear force. So the electron cycling over it are not permitted to leave their orbit. But the stationary orbit, that is outermost orbit in which electrons are present, they get excited by friction or by getting sometime heat energy. तो थोड़ी सी भी हीट एनर्जी या फ्रिक्शन एनर्जी इनको अगर मिल जाती है तो दे बिकम एक्साइटेड एंड जस्ट लीव आउट द ऑर्बिट. वो अपनी ऑर्बिट को क्या करते हैं, छोड़ देते हैं. नाउ आफ्टर लीविंग द ऑर्बिट दे स्टार्टेड टू मूव रैंडमली इनसाइड ऑफ द क्रिस्टल लैटिस एंड दे स्ट्राइकिंग द पैरेंट न्यूक्लियाई पॉजिटिव आयन, पॉजिटिव आयन को क्या करते हैं, लगातार कोलाइड करते रहते हैं। तो एक तरह का क्या होता है, इनके बीच में रैंडम मोशन होता है। तो दे आर मूविंग टू एंड फ्रो, बट होता क्या है कि द नंबर ऑफ फ्री इलेक्ट्रॉन दैट आर मूविंग रैंडमली हियर एंड देयर, द एवरेज वेलोसिटी बिफोर कनेक्टिंग द पोटेंशियल सोर्स, वो क्या होती है, लगभग उनकी जीरो होती है। तो अब यहाँ पे इन द केस ऑफ फ्री इलेक्ट्रॉन मॉडल वी आर गोइंग टू डिफाइन द टू टर्म, फर्स्ट free mean path, and after it second important time, relaxation time. Now what is the free mean path, इसको लैम्डा शो कर सकते हैं। फ्री मीन पाथ, तो path that is the length, तो the length traveled by the free electron before going to collision, टक्कर के चलने के पहले जो वो जितनी लेंथ फ्री होकर के चलता है, दैट इज कॉल्ड फ्री मीन पाथ। एंड रिलैक्सेशन टाइम क्या होता है, इट इज डिफाइंड द एवरेज टाइम, इसको मैं लिख देता हूं, द एवरेज टाइम टेकन बाय द चार्ज between two successive collision। तो व्हाट इज द रिलैक्सेशन टाइम, इसको टॉक से डिनोट करते हैं। तो बेसिकली द फ्री इलेक्ट्रॉन हैज रैंडम नेचर, वो रैंडमली क्या करते हैं, मूव करते हैं। तो ड्यू टू द रैंडम मोशन दे continuously striking the न्यूक्लियाई, पॉजिटिव न्यूक्लियाई, तो वो लगातार पॉजिटिव न्यूक्लियाई क्या करते हैं, लगातार टकराते रहते हैं। तो व्हाट इज द फ्री मीन पाथ, इट इज द फ्री मीन पाथ इज द डिस्टेंस ट्रेवल्ड before the successive collision and the time taken by the electron for the two successive collision, or the average time that elapsed between the two successive collision is called free mean path। सो दो चीजें हम जान गए कि एक तो पहला चीज क्या हो गया कि फ्री मीन पाथ क्या हो गया, फ्री मीन पाथ इज द डिस्टेंस ट्रेवल्ड बिफोर कोलिजन बाय द चार्जेस, एंड रिलैक्सेशन टाइम इज द average time that elapses or collapses between two successive collision, that is called relaxation time। Now we are going to find out the relation between, या एक चीज और देख लेते हैं पहले, ड्रिफ्ट वेलोसिटी। इसको हम लोग vd से लिखते हैं, इट इज अ वेक्टर क्वांटिटी, why, because it has a direction also। So before applying the potential we now know that the charges are in the condition of the random motion में होते हैं, but as soon as we apply the potential across the conductor, जैसे ही हम क्या करते हैं, कंडक्टर के across में एक तरह का पोटेंशियल इस्टेब्लिश करते हैं, तो the charges acquired the velocity, और ये वेलोसिटी बहुत ज्यादा नहीं होती है, ये लगभग 1 मिलीमीटर पर सेकंड होती है। ना यहाँ पे एक चीज और समझना है कि 1 मिलीमीटर सेकंड में क्या होता है, चार्जेस एंटर करते हैं एंड इन द सेम टाइम चार्जेस क्या करते हैं, बाहर भी जाते हैं। तो in 1 millimeter per second, so what is the drift velocity, as soon as we apply the potential across the conductor, the random motion of the electron which was initially before connecting the potential was random, इधर उधर क्या भी मन हो रहा था घूम रहे थे। now after applying the potential, the electron started to move with a velocity, एक वेलोसिटी से क्या करने लगते हैं, मूव करने लगते हैं, एंड दिस टाइम दिस वेलोसिटी इज टर्म एज अ ड्रिफ्ट वेलोसिटी। तो क्या क्या बताया हमने, पहला बताया आपको रिलैक्सेशन टाइम, फ्री मीन पाथ बताया और ड्रिफ्ट वेलोसिटी बता दिया। नाउ वी आर गोइंग टू फाइंड आउट व्हाट इज द रिलेशन बिटवीन ड्रिफ्ट वेलोसिटी एंड रिलैक्सेशन टाइम, इसके दोनों में क्या रिलेशन होता है। basically when we applied a kind of potential across the conductor, a kind of electric field generate, एक electric field क्या होती है, generate होती है, and this is given by V by L. Now this electric field imposed a kind of force over the electron, due to which it start to accelerate. फिर से समझिए कि when we applied the potential across the conductor, ultimately an electric field generate, एक electric field generate होता है. This will impose, अब इलेक्ट्रॉन अगर इलेक्ट्रिक फील्ड में है तो उसके पर इतना फोर्स लगेगा. Now electric field impose a kind of force over the electron, due to which it accelerate, and acceleration होने की वजह से they started to drift, and this time the drifting of the electron in the opposite direction of the applied electric field is called drift velocity. So a kind of force implemented by the electric field is given by what? F is equal to ma. Also we know that F is equal to Q ही होते हैं. Now by the both equation we can write here or we may write here A is equal to so this is what? This is the acceleration by which electron is moving just opposite direction of the electric field. Now it is since drifting with velocity, some velocity say Vd, and the average velocity हमको पता है कि average velocity इनकी सबकी क्या होती है, and so on un upon n, it becomes 0. So by the first equation of motion, V is equal to u plus at. Say what is the time here? Time is the average time that elapses between two successive collisions, that is nothing but the relaxation time, and initial velocity will become 0. Here the acceleration, and t become torque, and v become Vd. So this will become Vd is equal to a torque. So what is the relation between relaxation time and drift velocity? Is Vd a torque. Now we can place also the value of acceleration to this equation. We have here Vd is equal to now in terms of vector भी आप चाहे तो लिख सकते हैं इसको. So this is what? This is the relation between the drift velocity and the electric field, or we may say the relation between the drift velocity to the relaxation time. Now we are going to find out the relation between drift velocity and electric current. So we will take this figure. Now suppose that electron density of the conductor is n. That means n electron are moving from one point to the another point, and the cross sectional area of this conductor is A. So the actual number of charges that are moving throughout this area, n electron है, and charge on each electron is E. So the number of electron moving with each charge is Ne. Now where it is moving? In the range of the area with velocity Vd. So an electron is moving in t time. Suppose that it is moving in t time. So number of electrons that are moving in the cross sectional area A with velocity Vd in time t will be given by NEA Vdt. Now what is the charge? Electric current. Electric current is defined as the rate of flow of charge. Just we have to place the value of Q, that is calculated NEA Vdt upon T. तो T से T term cancel out हो जाएगा. Here the relation between electric current and drift velocity is I is equal to NEA Vd. So this is important relation. Sometime it comes in the board examination. Write the relation between electric current and drift velocity. इसके बाद एक अलग फिजिकल क्वांटिटी है, दैट इज कॉल्ड करंट डेंसिटी. नो करंट डेंसिटी इज डिफाइंड एज, इसको जे से रिप्रेजेंट करते हैं, इट इज अ वेक्टर क्वांटिटी. इट इज डिफाइंड एज I by A, that is current flowing per unit area in the cross sectional region, that is called current density. So अब we can also place the value of I, that is evaluated in terms of drift velocity. So what will be the relation between the current density and drift velocity? It will be given by NEAVD upon A to A term will be cancelled out, so the current density in terms of drift velocity will be NEVD. नोट कर लीजिए फटाफट. इसके बाद हम लोग क्या करेंगे, हम लोग इसके बाद चलते हैं ओम्स लॉ को. ऑन द बेसिस ऑफ फ्री इलेक्ट्रॉन मॉडल वी कैन आल्सो डिफाइन ओम्स लॉ. एंड अगेन सेम फिगर विल रन. फिर से ये फिगर हम लोग क्या करेंगे, यूज कर सकते हैं. तो हमें पता है कि as soon as we establish a kind of potential across the conductor, it ultimately generate a kind of field to which electron experience a kind of force, and after getting the force it get accelerated in the opposite direction of the electric field. इलेक्ट्रिक फील्ड में अपोजिट डायरेक्शन चलने लगता है, एंड दिस टाइम इट इज कॉल्ड ड्रिफ्ट वेलोसिटी. ड्रिफ्ट वेलोसिटी होगी. चलिए ठीक है. अब हम क्या करते हैं, फिर से ही बात दोहराते हैं. क्या F is equal to E into E, and what is electric field? Suppose that this time we are taking the length of the conductor L, so electric field is E is equal to V by L. So F is equal to E, take the value of this one, and what is F? F is Ma, so we can write it in place of Ma. Ma is equal to EV upon L, or A is equal to EV upon M को इधर भेज दीजिए, ML हो गया. Now we also know that VD is equal to A torque. Place the value of A here, so it will become EV upon ML torque. This is VD. Again we know that I is equal to NEAVD. अभी निकाला इसको. Now place the value of VD here. तो I is equal to हो जाएगा क्या, NEA, what is the value of VD? EV upon ML torque. Now this term may be written as NE square A, V को इधर सेंड कर लीजिए, I by V upon ML torque. Now what is I by V or V by I? तो V by I is equal to ML upon NE square A torque, and V by I is nothing but it is the constant ratio resistance R. So R will become equal to V by I. ये सारे कांस्टेंट कलेक्टिवली क्या होते हैं, आर बोलते हैं. And in terms of numerical, we have to place the value of all this to find out the resistance also. तो R is equal to क्या हो गया, V by I is equal to ml upon n square A torque is equal to constant. So this is the proving of Ohm's law. Ohm's law हम लोग पढ़ते चले जाते हैं. Now here we are just able to derive Ohm's law. That is V by I is equal to constant. एंड आर, ये इसको हम क्या करते हैं, प्रूव करते हैं. तो फिर से एक बार देख लेते हैं कि वी हैव टेकन द कंडक्टर ऑफ क्रॉस सेक्शनल एरिया ए ऑफ लेंथ एल, वी हैव एस्टैब्लिश्ड द पोटेंशियल एंड जस्ट एस्टैब्लिश्ड द पोटेंशियल, द इलेक्ट्रॉन गेट एक्सेलरेटेड or drifted in the opposite direction of the applied electric field, and this time the electric field impose a kind of force over the electron is given by F is equal to EE. Now we also know that electric field in terms of potential gradient E is equal to V by L. Just place the value of V by L in the equation here. इसको नंबर कर लीजिए, थोड़ा सा दिक्कत हो रही है तो. Now place the value of E. E की वैल्यू यहाँ पे रख दीजिए. Now in terms of E, the force changes into EB upon ml. Now again we know that force is equal to mass into acceleration. So ma will be equal to EB upon L, or acceleration will become EB upon, just place the value of m here. So this is the acceleration. Now again we know that the relation between drift velocity and electric current, I is equal to n here Vd. Just we have to place the value of A, whatever calculated, or just place the value of Vd is equal to 8 torque in there in this equation. So Vd is equal to EB upon ml torque हो जाएगा. Now after this we have to place the value of Vd in the equation. I is equal to NEA Vd, यहाँ Vd की वैल्यू रख देंगे. और आफ्टर दैट फिर हम लोग क्या करेंगे, V by I का रेशियो निकाल लेंगे. एंड द रेशियो ऑफ V by I, m कांस्टेंट, l कांस्टेंट, सारी चीज कांस्टेंट ही तो है, ठीक है. So that constant value will collectively give the resistance. And this is the free electron model. On the basis of free electron model we have proved Ohm's law. फटाफट नोट कीजिए. चलिए बच्चों, तो नोट कर लिया इसको आपने. बच्चे बहुत स्मार्ट होते हैं, नोट करने से ज्यादा बेटर समझते हैं. स्क्रीनशॉट ले लो, स्क्रीनशॉट ले लो. नो ये सारी चीज तो हो गई भैया. नो वी आर गोइंग टू रेजिस्टेंस अगेन, and we'll try to know what are the factors that affect the resistance. रेजिस्टेंस में कौन कौन. तो टेम्परेचर की बात तो हम लोगों ने पहले भी कर ली कि टेम्परेचर क्या करते हैं, अफेक्ट करते हैं. तो रेजिस्टेंस अभी बेसिकली हम लोग क्या करते हैं, बात करते हैं लेंथ ऑफ द कंडक्टर एंड क्रॉस सेक्शनल एरिया से अगर हम रिलेट करते हैं तो विल फाइंड दैट रेजिस्टेंस इज सम टाइम डायरेक्टली प्रोपोर्शनल टू लेंथ and inversely proportional to the cross sectional area. Collectively we can write that resistance is directly proportional to L by A, and यहाँ पे आ जाता है R is equal to rho L by A. इतने फिजिकल क्वांटिटी आ गई. रो इसको पढ़ चुके हैं आपको. Now रो क्या हो गया, रो इसको बोलते हैं हम लोग, क्या बोलते हैं, स्पेसिफिक रेजिस्टेंस. तो भैया ये भी एक तरह का रेजिस्टेंस ही है, ठीक है, बट ये क्या है, स्पेसिफिक है. सो हियर वी हैव R is equal to rho L by A. Rho is the proportionality constant known as specific resistance या resistivity भी इसको कह सकते हैं. Now we are going to define what is the resistivity. For R is equal to 1 ohm या for L is equal to 1 meter, A is equal to 1 meter square. R is nothing but the resistivity. So specific resistance is that resistance which exists across the conductor when the length of the conductor is 1 meter and the cross sectional area is 1 meter square. बस हो गया काम खत्म. तो रो बराबर क्या हो गया, R A by L. Now what is the value? Now we are going to just find out the unit. So unit क्या होती है भैया, R की ओम, A की मीटर स्क्वायर और लेंथ की मीटर. मीटर टू मीटर भी कैंसिल आउट एंड आ गया क्या, रेजिस्टिविटी. नो एक चीज और जान लीजिए क्या, कि रेसिस्टिविटी का रेसिप्रोकल जो होता है उसको क्या बोलते हैं? कंडक्टिविटी। एक चीज और जान लीजिए, क्या? कंडक्टेंस। द रेसिप्रोकल ऑफ रेजिस्टेंस इज कॉल्ड समटाइम कंडक्टेंस। तो रेसिप्रोकल ऑफ रेसिस्टिविटी इज कॉल्ड कंडक्टिविटी एंड रेसिप्रोकल ऑफ रेजिस्टेंस इज कॉल्ड कंडक्टेंस। तो आज के लिए इतना बहुत है। नेक्स्ट वीडियो में अभी हम इसी पार्ट से, ओम्स लॉ से रिलेटेड, इसको और चीजें डिस्कस करेंगे। जैसे एक चीज और अच्छा कर लेते हैं जल्दी जल्दी में कि इसको आप करिएगा, ओम्स लॉ इन वेक्टर फॉर्म। इसको आप करिएगा, ठीक है? और करके बताइए, देखो आप कर पाते हो कि नहीं। इतना पढ़ाया है यार, इतना तो करो। ओके, थैंक यू सो मच, हैव अ नाइस डे।